Welcome to my channel, and let's look at how to find inverses of higher order matrices using the method of adjoint. Now, we already know how to find the determinant of matrix, and that is very important in this topic. So the following steps are used for us to get the determinant of higher order matrices. No, the inverse of higher order matrices. So the first thing that we do to get the inverse of higher order matrices is to find the inverse of the matrix. So supposing I'm given matrix A, then the first thing I will do is to find the determinant of matrix A. And then I will proceed to find the cofactor matrix of matrix A, and then find the adjoint of matrix A. So for higher order matrices, the adjoint of matrix would be the transpose of the cofactor matrix that we obtained in part 2 here. So this part 2 is not this. It's part 2. So the transpose of this matrix in part 2 is the adjoint of that matrix. So once we have this adjoint, and you remember that the inverse of matrix A is 1 over determinant times the adjoint of matrix A. Let me remind you how to find the adjoint of a 2 by 2 matrix. So if I have a 2 by 2 matrix, A, B, C, D, if this is a 2 by 2 matrix. So what is the adjoint of this matrix? So the adjoint of this 2 by 2 matrix, I'll abbreviate it as adj. So the adjoint of this matrix, supposing this is matrix A, so the adjoint of this matrix A is the matrix that you get when you interchange this D, A, and then interchange the signs. No, if the sign is positive, then it must be negative this time. And this is also positive, so you have negative. So just change the sign. So if the sign was positive, it becomes negative. And if it was negative, it becomes positive. This is the adjoint of this matrix. For a 2 by 2 matrix, that's what we do. Now, so what is now important for us is how do we get the adjoint of a 3 by 3 matrix, a 4 by 4 matrix, and a 5 by 5 matrix, and so on. And that's what I've written in. That the adjoint of matrix A of higher order will be the same as the transpose of the cofactor matrix that we obtained in the transpose. So again, let me just remind you what the transpose is. And the transpose of a matrix is the new matrix that you obtain when you make the rows become columns, or when you make columns become rows. So for example, if this is the matrix A, B, C, D, E, F. So the adjoint of A, now the transpose of A, which we denote as A transpose, will be the matrix you obtain when you make the first row be the first column, the second row be the second column, and so on. So this is the transpose of this matrix. Now, so what now remains is for us to learn how to get the cofactor matrix. Once we know how to get the cofactor matrix, we shall get the transpose of that cofactor matrix, and that will give us the adjoint of matrix. And then once we have this adjoint, and we have the determinant of the matrix, it's now easier for us to get the inverse of that matrix. So let's look at an example. So this is my example, and the question says, using adjoint method, find A inverse if A is this. Using adjoint method, find A inverse if A is this. So the first thing we do is to find the determinant of A. And since A is a 3 by 3 matrix, I chose on the simplest way to find the determinant of A. And so I write, as we looked at the previous, as we did in the previous video of finding the determinant of matrices, I wrote matrix A here, and then took these first two columns and added them here. The first two columns, added them here. So I have these diagonals, three diagonals, running from left to right. These three diagonals, I multiply along this diagonal and add. You can see this is plus. So I add, this is -5 plus, this is -6 plus, and this is -8. And then minus these entries, minus, this is -10, and this is -6, and this is -4. So when I do this, I get the determinant to be 1. So I now have the determinant. What I want to look for is the cofactor matrix. And then, after getting the cofactor matrix, I'll find its transpose, and that will give me the adjoint. So the cofactor matrix, let's just remember what our matrix was. Let me write what the matrix was. No, the matrix, I can just get it from here. It was 1, 2, -4, -1, -1, 3, -1, -2, 5. So that is the matrix. Now, so to get the cofactor, I get the cofactor for every element. I get the cofactor for every element. So for example, this element here, its cofactor would be the determinant of the matrix that remains when I delete the row of that element and the column of that element. So when I delete the row of 1 and the column of 1, the matrix that is left is this: -1, 3, -2, 5, -1, 3, -2, 5. And then I come to the second element is 2. I get its cofactor. So I delete the row of 2 and the column of 2. The matrix that is left is -1, 3, -1, 5. So -1, 3, -1, 5. So you may be asking, what about this sign? And this sign we already discussed in the determinant when we were looking at the determinants of matrices, and we said that if our matrix, you see this is our matrix, 1, 2, -4, -1, -3, no, this is -1, 3, and this is -1, -2, 5. So we said that the sign for this element will be positive, this will be negative, this 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 will be positive. And they alternate. And that's why you can see I put a positive here, and I put a negative here. A positive, negative, positive, negative, positive, negative, positive. So they alternate. Okay, so that's how we find those signs. So we were done with this element and this element. So we come to this other element, and we want, and remember, this is not part of the matrix. This is not part of the matrix. So our matrix was this. This was our matrix. This one we just used it to get the determinants. Now, so we want the cofactor for this element, for this position here. And so this position is in row 1, column 3. So when I delete row 1, column 3, I'm left with this. I'm left with this. -1, -1, -1, -2. And that's what you see. It's a plus. Now I come to this element, delete its row, and delete its column. So I'm left with 2, -4, -2, 5. 2, -4, -2, 5. And the sign is negative. Remember that the signs are alternating. So now let's come to this other element here, the element in row 2, column 2. And remember that this is not part of the matrix. So our matrix remains to be this. So we are on this element. So we delete the row of that element and then the column of that element. We're left with 1, -4, -1, 5. 1, -4, -1, 5. And the sign is positive. Then the next element is this, delete its row and its column. The matrix that is left is 1, 2, -1, -2, 1, 2, -1, -2, and the sign is positive. Remember, the signs were alternating. And so let's now go to the last row. This element, the column, and not the row, and then the column deleted. We are left with the 2, -4, -1, 3. 2, -4, -1, 3. Then the next element is this, delete its column and then its row. We are left with 1, -4, -1, 3. 1, -4, -1, 3, and the sign is negative. And then lastly, this element, delete its row and then its column. We have 1, 2, -1, -1, 1, 2, -1, -1. So we've now done that. We only need, what remains is now just to find the determinants. So let's just now find the determinants. And so when we do that, this is what we get. This will be -5, -5, and -6. This gives us +1. Now what about this? This will be -5. There's a minus outside, but inside we have -5 -3. So this becomes positive. So this is -2 times negative, which is +2. What about this? This will be 2 -1. The sign here is positive, so it's 1. So we do that for all the elements, and this is the cofactor matrix. That becomes the cofactor matrix. So remember, we said once you have this cofactor matrix, you get its transpose. You get its transpose. And so what is the transpose of that? We say we shall make the rows become columns, and or make the columns become the rows. So when we make this first row be the first column, yeah, the transpose is that. So first row be the first column, second row be the second column, and the third row be the third column. So this is the adjoint of our matrix. This is the adjoint. Now, so what is the inverse? The inverse of A is 1 over the determinant times the adjoint. So remember our determinant was 1. So times the adjoint. So we just remember the same adjoint is the inverse. So this is the inverse of matrix A. Let's look at another example to make our working clear. So here is the question. And the question says, use adjoint method to find the inverse of this matrix. Remember, this power means inverse. Power -1 means inverse. So again, I've chosen on the method that I said would be easier for a 3 by 3 matrix to find the determinant. So we find the determinant, we have this matrix, we write it here, and then add the first two columns here, and multiply along this diagonal and add, along this diagonal and add, this other diagonal and add. And then subtract the product along this diagonal, subtract the product along this diagonal, and subtract the product along this other diagonal. When that happens, we find our determinant as negative 26. From there, what the next thing is for us to get the cofactor matrix. So what was our matrix? Let's just write what our matrix was. Our matrix was 2, 1, negative 2. Just a minute. I want to create a space to write that matrix. It was 2, 1. Let me just write it on a piece of paper and then I get a place to write. So the matrix that we were given was 2, 1, negative 2, 3, negative 3, negative 1, and then 1, negative 2, 3. So let me just write it somewhere now so that we use it to find the cofactor matrix. Good. Let me now write it here. Let me just write the matrix that as we refer to it, it becomes easy. So the matrix is 2, 1, negative 2, and 3, negative 3, negative 1, and then 1, negative 2, 3. This is the matrix. So we want to get the cofactor matrix. We got this, we go for this first element here. And remember the sign will be positive, negative, positive, negative, positive, negative, positive, negative, positive. So that is how the signs will alternate, and that's we already talked about that. So to get the cofactor in this position, delete first row, delete first column. We are left with this matrix: negative 3, negative 1, negative 2, 3. Find its determinant. And then the sign, next sign is negative. Now we are in this position. Delete the row and the column. In this position, delete the row and the column. We are left with the 3, 1, negative 1, 3. 3, 1, negative 1, 3. The next sign is positive. We are here. The next sign is positive. Delete this row and that column. This row and that column. So you are left with the 3, negative 3, 1, negative 2. 3, negative 3, 1, negative 2. Then finally, next, this was positive, negative, positive. This will be negative. So in this position, delete this row and delete that column. So level 1, negative 2, negative 2. So we do that for all the other elements. Do that for all the other elements, and then you find the determinant. Find the determinants, and this is the matrix you end up with. This is the cofactor matrix. This is the cofactor matrix. Now, so we find its the adjoint by finding the transpose of this matrix. So this is the matrix we have. So let's find the transpose. Make this first row to be the first column. This second row be the second column. This third row be the third column. So this is the adjoint matrix. So our question was to find the inverse. And the inverse is 1 over determinant times the adjoint. And this is our determinant, negative 26. So 1 over negative 26 times the adjoint. And if you want, you can leave your answer at this point. or you can take these values inside. So when you multiply inside, this becomes positive 11 over 26, this is negative 1 over 26, this is positive 7 over 26, and so on. So this is the inverse of this matrix. And this is how we find the inverse of matrices by use of adjoint.